Okay, so we have been talking a lot about multiplication. We learned the new word equation the other day. So let's look at these equations, okay? And remember I said vocabulary is important, so we're going to practice. What is the product of these equations? So here's an equation. 2 times 3 equals 6, right? This is an equation because it has the equal sign and it's telling you that this is equal or has the same value to 6, okay? So, yes, 6 is the product. If I showed you 30 equals 5 times 6, what is the product? So, put something in Google Chat. Out of these numbers, out of 30, 5 times 5, what is the product of that equation? Is it the 30? Is it the 5? Is it the 6? What's the product? What's the answer to the multiplication problem? It's 30, right? How about if we look at this equation? 3 times 4 equals 12. It's an equation because it has the equal sign. It's telling you this has the same value as this, right? We know that product is the answer to a multiplication problem. So in chat, out of these numbers, 3 times 4 equals 12. What is the product? Put something in Google Chat. Okay? All right, we should have 12. All right, and I just switched it up a little bit here. Out of this equation, 3 times 7 equals 21. This is an equation. Okay, it's a multiplication equation. We can have addition equations, subtraction equations, right? But this is a multiplication equation. And now I'm asking which numbers are the factors. So is it the 3, the 7, the 21? And I'm going to tell you that there's more than one factor here. There's 2 factors. If we know that product is the answer, what are the factors, right? The factors are the numbers we multiply. So 3 and 7 are the factors of 21. 21 is the product. 3 and 7 are the factors. Okay? So just looking at it a different way. All right, so let's look at what we're saying. Okay, again, we're reviewing our multiplication tables. So 24 equals 3 times 8. So this is an equation. Okay? So what I'm saying is 24 is blank times as much as 8. So if I had 8, how many of the 8s do I need to get 24? Right? And again, we're not looking at any of the numbers. They're telling us right here. What this says is 24 is 3 times as much as 8. Right? It's 8 3 times. That's what we're saying. Okay? Let's look at this. 30 equals 3 times 10. So in this equation, because it has an equal sign, right? 30 is the product. 3 and 10 are the factors. 3 times 10 does equal 30, right? So we're saying 30 is blank times as much as 10. So how many 10s do we need? 3, right? So this is true. 30 is 3 times as much as 10. It's just a different way to say it. Now again, I could have said 30 is 3 times as much as 10, right? Again, I'm using the same numbers here. 30, 3, 10. I'm not coming up with any new numbers. Right here, 24, 3, 8. Here, there's my 30, there's my 3, there's my 10. Here, same equation actually. 30, there's my 3, there's my 10. Okay, this is just also another way for us to keep practicing our multiplication tables, right? More exposure. So here's an equation. 3 times 4 equals 12. 3 and 4 are the factors. 12 is the product. And we could say 3 times as many as 4 is, right? So if we did 3 times 4, That's what we're saying. What would our answer be? 12. 28, let's look at this equation. 28 equals 4 times 7, right? 28's the product, factor, factor. All right, so I can say 28 is blank times as much as 7. So how many 7s do we need? Right? It tells us right up here. 4. All right, let's look at this last equation. Our last multiplication equation. 42 equals 7 times 6. All right, so in chat, just tell me what the product is of this equation. Out of these numbers, okay, so your only choices are 42, 7, or 6. Which one of these numbers is the product? Okay, remember, what does product mean? Product means the answer to a multiplication problem. So which one of these numbers are the product? Okay, right, so hopefully you put 42. All right, and let's look at this sentence here. 42 is 7 times as much as what? 6, right? So let's just say someone is 42 years old, okay, and someone is 6 years old. And you want to know how much older, right? Well, they're 7 times older than this child. 7 times. They've lived that life 7 times. 6, they did 6 years, 7 times. 6 times 7 is 42. Okay, so that's our review of multiplication, what an equation is, factors and products, and then some language, how, we're talking about what this really means. 42 is 7 times as much as 6. Okay? All right, so we've been talking about area of shapes. We've been talking about area of rectangles, right? We know that area, area, array. We're talking about multiplication, right? So, and it's the measurement of the inside of a shape, okay? So we don't want to forget that. We are moving on, but we don't want to forget the knowledge that we've learned, okay? So now we're going to investigate polygons. And the polygon is another new word. I don't know if you've ever heard of polygon, but it's really just a fancy word for shapes, okay? Okay, so we're investigating shapes. Now, a lot of these shapes you have definitely seen before. I mean, all of them you've seen before, without a doubt. And I'm sure you can identify them, but you might not know what makes it that. Okay, so we're going to talk about the definition. So a square has we know a square has 4 sides, right? But when we get to 3rd and 4th grade, we want to start talking about the equal sides and 4 right angles, okay? And what an angle is a corner, okay? And angles can be fat, they can be skinny, or they can be a right angle, okay? And so I gave you this as a square, okay? Now we could look at this, right? That's why I wanted to give you a no and a definition, because this has 4 sides, 1, 2, 3, 4. But this is not a square, right? A square has to have equal sides and 4 right angles. And I like to just describe when we can measure angles with a protractor, right? And those are fun when we get those. But I just like to, you can really tell a right angle, even this little cursor right here. Those are all right angles inside a corner. So I like to look at it as this, the right angles make an L, okay? So these all make L's, no matter how we look at them, okay? Look at our angles here. This is a skinny one. This is a fat angle, right? Let me see if I can see if there's a shape that I could just, maybe if I just do this, look, if this is our angle, to turn it. See, that's our angle right there. That point, maybe what looks like an ice cream cone, right? That's a skinny angle. This would be our fat angle. Okay, so let me just do another shape here. See, that's my angle. Let's push it down a little bit. See, there's the angle. If you were to look at that, right, like a baseball field, right? That point is the angle. That's a fat angle. That's a skinny angle. That's a right angle. And the fat and skinny, they have different, obviously in math, I don't call them fat and skinny, but I'm just trying to let you see, right? That's a skinny angle, that's a fat angle, but they have math terms, but I don't want to overload you with terms right now. So we're just going to call them fat and skinny, okay? For right now. But we'll get back to that. Angles are important. All right. So here, a rectangle. So square, very common, but now you know the definition and why this is not a square, right? I may say to you, why is this not a square? Well, Ms. Fox, it doesn't have all, the sides aren't all the same. That's one reason. The other reason, the angles, they don't have right angles. They have fat and skinny angles, okay? Here, a rectangle. Again, another common shape that you can identify. And we talked about rectangles, doing the area of rectangles. So this is a four-sided shape, again, with four right angles. So why isn't this a square, right? Well, because the opposite sides, and I had showed you this, A, B, B, right? The opposite sides are equal length, okay? So A. These are also called parallel for future reference, okay? These are parallel, they're never going to touch. But this is what a rectangle is, okay? Triangle. Look at the word angles in there. Tri, like tricycle, and that's why I did that. It's a three-sided shape. There's three sides and three angles. Now, this is just a basic triangle, again, that you've been seeing for a few years now, okay? They have names for different kinds of triangles. Again, we're not getting into that today or right now. For right now, we just need to know that a regular triangle has three sides and three angles. So this is a triangle, 1, 2, 3. This is a triangle, 1, 2, 3. And this is a triangle, 1, 2, 3. Now, these triangles do have special math names to them. But again, we're not going to get into the special kinds because we start to look at the angles of the triangles, but that's a little bit later. We don't have to do that for this lesson, okay? So we just have to know that a triangle has three sides. There are triangles with different names, but we're not doing that today. All right, and then the hexagon. A hexagon is a six-sided shape with six angles. So this is what the basic hexagon looks like. Okay. Again, they can make it fat or skinny or squish it a little bit, right? Flip its side. So you have to be able to know, oh, okay, well, it doesn't look like that one, but let's count. 1, 2, 3, 4, 5, 6. This is a six-sided shape. So you got to be able to count the sides. Here, this doesn't look like either one of these, but 1, 2, 3, 4, 5, 6, right? And there's our angles. So 1 point, 2 point, 3 point, 4 point, 5 point, 6 points. Okay? So 6 sides. 1, 2, 3, 4, 5, 6. Okay? And 6 angles. Corners, points, right? Circles. So circles don't have sides or angles, and they're closed. And so this is an obvious circle, right? Now, I couldn't find anything that wasn't closed, but let's say that didn't connect. Let's say there's a little teeny space right here, right, that we could go in and out of. Then that wouldn't be a circle. It wouldn't be closed. But this, all of this connects, right? And there's no lines. These are not circles because look, here's a line and here's a line. And actually those two lines make an angle. This one has an angle. Actually, it has a right angle. See how this looks like an L? So that's not a circle. And this one is not a circle because it's got the curved line. I should say, yeah, it's got the curved line, but no straight lines, right? And then here's a straight line. So that straight line makes it not a circle. Okay? And then I just put this in as a quick reference that you may want to look at from time to time, right? So a circle, a semicircle, semi means half, so a semicircle would be half. Triangle, we will be talking about probably these in the future. Let's see if I can, obviously triangle, we're talking about that now. We're not talking about quadrilaterals right now, but that will be in the near future. Pentagons we'll probably talk about too. We are talking about hexagons right now. We'll talk about octagons and pentagons. I think that's okay. So these are the future. So these are good, kind of like a cheat sheet. All right. And actually decagon, right? Deca means 10. So, and again, if you learned all of them, it's not going to hurt you. So this is a quick little cheat sheet, a reference sheet. All right. So again, square, 4 equal sides, 4 right corners. Right? Rectangle, 4 sides. The opposite sides are the same length and it has right angles. Right? Triangle, for the sake of this purpose, these, yes, are all triangles. They all have 3 sides and they all have 3 angles. See how this is a skinny, skinny, skinny angle? Right? Skinny, skinny, skinny. This is a right angle. Skinny angle, skinny angle. Right? So see, look at your angles too. And we can just call them fat and skinny for right now. But they do have different words for them. Right? If we look here, these are, we could call them large angles. These are all large angles. Right? Look at your angles, right? This doesn't have any tiny or baby angles. Yeah, sometimes I don't call them fat and skinny. I usually call them large and baby because you'll see when I do give you the definition, the baby angles, right? Like a baby angle, it makes sense to the definition. So the baby angles, large angles, and right angles. And right angles look like L's, right? And even if I flipped this, okay, let's flip this, all right? Let's put this here, okay? This is still a right angle, right up here, right? So sometimes, so this is like a backwards L, but you see how it's like room corners are usually right angles, okay? Most room corners, it's that nice sharp angle. And again, there are tools to measure it called protractors, but we don't have those. And we don't need those for what we're doing, okay? So we're going to stop there and we're going to talk a little.